All right, so in this video, we'll be going over this MIPS code here. We'll be going line by line just to see what every line does individually. And at the end of the video, we're going to be putting together like the code, and we're going to see what the actual purpose of the code is, right? So to begin, we can start off at begin, right? And what is this code? What is this piece of code here doing? It's a well in MIPS they call it a label, right? It's kind of just a location in our code. And I guess like the best example I can use is kind of like look at this line for a second, right? What is this saying? It's saying jump to label loop, right? So if I execute this line of code, what am I going to do? I'm actually going to go find the label loop, and I'm going to jump to it, and I'm going to run this line, right? So that's what these three are. They're labels in MIPS, right? They're sort of jump locations, if you will, right? So that's what this begin is just saying. You can kind of tell it's a label because it has like a word that doesn't really look like code. It kind of looks more like English, and then it has a colon next to it, right? Okay, so that's neither here nor there. Let's look at the rest of the line, right? What do I have? I have add immediate. When I have like add and I or like anything with the immediate flag on it, so to speak, right? It typically means that I'm doing something with a constant, right? What is the constant in this case? The constant in this case is zero, right? I'm doing something with zero. What am I doing with zero? I'm adding it to something else. I'm adding it to the zero register, right? Now, why would I be doing that? Well, in MIPS, I can't guarantee that this register, T0, is initialized to zero, right? I can't guarantee that. Maybe it has some garbage value from the last program you ran, right? So I cannot guarantee that T0 is blank. I can't guarantee that it has a zero. So what am I going to do? I'm going to add a constant zero to the register zero. And by the way, this register always holds the value zero, right? So I'm going to add zero to zero, and I'm gonna place that result inside of T0. So now this is my guarantee now that T0 is in fact initialized, right? So what I'm gonna say, I'm gonna put our little hashtag here for a comment. I'm gonna say T0 is initialized here, right? I'm just initialized to the value zero, right? That's all this line is doing. It's adding zero plus zero and it's placing it inside of this register. Okay, what's the next line doing? It's another add immediate line, right? And typically when you have like these three sort of values, right? I'm typically doing an operation on these two, and I'm placing the result of that operation within this first register here. So this is like the sort of destination register, and these are the source registers. This is really a constant right now, but like sometimes you'll have a register here, and this won't be add immediate, but we'll get to that in a bit. So what am I doing here? Remember the zero register always holds the value zero, and here I'm adding zero to this constant one, and I'm placing that result inside of T1. So what am I doing here? I'm really just I'm initializing T1 to the value one. So it's like in C, you can kind of think of it like this, right? If this is if I have some integer T0, I'm just saying it's equal to 0 plus 0, right? And if I have this integer T1, right, I can kind of think of that as 0 plus 1, right? It's being initialized to this value. Okay, that's like the sort of like corresponding C code, but that doesn't really matter now. It's not necessary to understand the code, right? What are we doing here, right? I have another label. It's called loop, right? It's probably indicating that this is the start of a loop, either for or while, but we'll investigate that in a bit. What are we doing in this line, right? This is a set on less than operation. Remember, this is the destination register. These are the sources, right? So I'm going to be asking, is A0, is the value inside of A0 less than the value inside of T1, right? If so, I'm going to assign the value, or I guess I'm going to assign the register T2 to the value true, or in other words, to the value 1, indicating that yes, in fact, A0 was less than T1. If not, so say if A0 were equal to T1, or say A0 was greater than T1, then I assign T0 the value, or T2 the value false, right? I assign it the value 0, right? So I can kind of say, like if A0 is less than T1, uh, T2 equals to 1, otherwise uh, T2 is equal to false, right? That's our sort of comment there. Now, what is this? What is this doing? I believe this is like a branch not equal to, or I don't know if I'm getting the words right, but here's what it does, right? If T2 and the 0 register do not share the same value, right? So this is always 0, but let's say that T2 was assigned the value 1, right? So I have 1, 0 here. Since these are not equal to each other, right? I'm actually going to go to the finish label, right? So I'm going to go down here. I'm going to run this line of code. If T2 takes on the value 0, because this is always 0, right? If these are equal to each other, then it's kind of like I just go to the next line. I kind of ignore this line, right? Because these were equal to each other. This is the branch not equal to piece of code or operation. So it only really works if the value within T2 and 0 are different, if they're not equal, right? So I'm just going to say if T2 is not equal to 0, jump to finish, right? And then let's just go to the next line of code here, right? I have add, not add I, right? So I'm probably dealing with two source registers, not a constant here. Right, so I have add, this is the destination register, and these are the two source registers. So what am I really doing here? I am taking the value inside of T0, and I'm adding it to the value inside of T1. And what am I doing then? I'm just going to place it inside of T0. This is totally allowed. You can have T0 as the source and the destination. It's kind of like if I did this in C, right? If I had T0, which is already declared as an integer, if I did plus equal to T1, or if I did like say like T0 is equal to T0 plus T1, right? These are two equivalent pieces of the code, with the semicolons, of course. It's just taking T1 and adding it to T0. Same thing here. I'm taking T0 and T1 and I'm putting inside of T0, right? So this is all that's doing, right? So just add T1 to T0, right? So now 0 takes on the sum. Here we have add immediate. What am I adding? I'm adding 2 to T1, and I'm placing the result of this addition inside of T1, right? So again, in C, right, what would this look like? It's like T1 uh, plus equal to now a constant, 2, right? So what is this doing? I'm just adding 2 to T1, right? That's all I'm doing. And again, right, we have this next line here. It's just saying that I need to jump to the label called loop, right? So basically, no matter what, I have to jump back here, and that's kind of what gives you that looping mechanism, right? That's how we get to this line. That's how we get to this sort of conditional statement here, right? So I'm just saying, if I run this line of code, all I'm doing is I'm going back to this line, and I'm running this line, and I'm basically going down again until I hit this again. Right, so what do I have here? So we already ran past this, so this is simply jump to loop label, right? And then here we are just remember how I said most of your registers are not initialized, right? So what I'm doing here is I'm taking the value of T0 and I'm adding it to the register 0, right? Because this always holds the value 0. Right, I probably could have done an add initial and then placed a 0 here, but they're two equivalent pieces of code, right? So it doesn't really matter. So what am I doing? I'm just placing the value of t0. I'm adding it to 0, and I'm placing that inside of v0. Now, what is v0? It's kind of like a return register, right? It's the register where you would put the final result that you want to give back to the caller, right? Who called this function? They're going to get back v0, right? So really, it's just initialize, not int, initialize v. Yeah, I guess that works. V0 to T0, right? Because adding 0 to anything isn't going to affect that anything, right? So adding 0 to T0 is just saying let's place T0 inside of V0, right? Okay. So what is the purpose of the code? Well, let's look at it again line by line, but then like kind of like denote things. So I guess like we'll be tracing through this code now, right? So what are we doing at the begin label? It looks like that I'm initializing t0 to 0, right? So okay, let's take note of this. I got t0 is equal to 0. Okay. Now what am I doing here? It looks like I'm initializing t0 or t1 to 1, right? Okay. So we got t1 is equal to 1. Okay, so now I've entered my loop, right? What am I doing? This is our input, by the way. The A0 is the input. And then T1, we already know what T1 is. Okay, so let's pretend that the input was, I don't know, say 3, right? So I'm gonna say that A0 was equal to 3. Okay? So what am I doing here? I need the value well, I don't need the value T2. I need T2 just here. And what am I doing? I'm seeing if A0 is less than T1, right? Okay, so what is A0? It's 3, right? So 3 less than 1, right? This is a false statement, right? So what is T2 going to take on the value of, right? T2 is going to be assigned the value false, right? Because this is a false statement, right? So what does false look like in code? It looks like 0, right? Okay, so now we can move on to the next line here. What is this code? What is this piece of code saying? It's saying that if T2 and 0 are not the same, I jump to finish, right? But look at T2. T2 is assigned the value 0. And what is 0? 0 is, well, 0, right? The 0 register holds the value 0. So 0 is equal to 0, meaning that I don't jump to finish, right? Because I only jump to finish if these two were different. These two are the same, right? So I move on to the next piece of code. I'm adding T0 to T1, right? So where's my T0 and my T1? Well, T1's right here and T0's right there, right? So what am I going to do? T1 needs to go into T0, right? I need to add it. So 0 plus 1 is 1. And down here, I'm adding 2 to T1, right? So I'm just gonna kind of cross this out, and we have a 3, right? Because 1 plus 2 is 3, right? So now I'm going to be jumping to the loop label, right? And what am I going to do now? I'm just going to run the instructions again, right? Until I break out of the loop. And how do I break out of the loop? By running this line and it running true, right? Okay. So here's what we have. I'm on my set on less than line. I'm looking at A0 again. A0 doesn't change, so it's 3. Is that strictly less than T1? Now, what's T1? It's 3, right? So, okay. Is 3 strictly less than 3? No, right? They're equal to each other. So what am I going to assign T2? I'm going to assign T2 the value false again, right? Because 3 is not strictly less than 3. Okay, so now we're here. We look at the value T2, it's 0. We look at the value of this register, it's also 0. So because they were the same thing, this line doesn't really jump to finish, and we just go to the next line. Okay, so what are we doing here? It looks like we're doing T0, and we're really just adding T1 to it. Okay, so what is T1? T1 is 3. So what is 1 plus 3? Terrible addition sign, but 1 plus 3 is 4, right? So that's what T0 is going to take on the value of. And now T1 is just going to be added to, I guess I'm adding 2 to it, right? Okay, so now T1's 5. Now I'm back here. I'm jumping to the loop. Okay, so now I do a set on less than, right? So A0 is always 3, but now T1 has been updated. T1 takes on the value 5. This is 5, right? Is this a true statement? Yes, it is, right? So T2 gets the value 1 now. So I'm over here. I'm assigning I guess T2. I hope I said T2 before. T2 takes on the value 1, right? So now I go to this line now, right? Are T2 and 0 different, right? So is 1 different from 0? Yes, of course they are, right? So what am I going to do? I'm going to jump to the finish, to the finish label, or the finish location, right? So what am I going to do? I'm going to basically give T0, like T0's value, to V0, the return address, or register, the return register, right? So now V0 is equal to whatever T0 is. So T0 is 4, right? So V0 is 4. Okay, so then we would return this value. Now, what really happened, right? Why did we do this? Why did I place the code where I placed it? And what does this code actually do? Because sure, we know that it loops, it adds some stuff, but what did it actually return to me? What is the purpose of this for? Well, if you look at T1, right, the values that it previously took on, so like 1, 3, and 5, you notice that they're all odd integers, or yeah, odd integers, right? And we just added the ones that were less than or equal to the input, right? So if I would have said 7, right, I guess if A0 would have been 5, or I think even 6, right? I would have had 1, 3, and 5, and then the next number in line would have been a 7, because I remember I would have added 2 to the current value of T1, right? So I would have had a 7 here. And then I would have realized that 7's too great, so I'll just add these odd integers, right? So I return, 4 plus 5, I return 9 in that case. So what I'm saying is that this code is going to add up the odd integers, right? Odd because T1 was initialized to 1, and then I just kept adding 2 to that 1. So 1 plus 2 is odd, plus another 2 is going to be odd, plus another 2 is going to be odd. What this plus 2 does, is it just gives you the next odd number in line, right? Had T1 been initialized to 0, it would have given you the next even number in line, right? So what all this code is doing is it's adding up the odd numbers that are less than or equal to, right? Less than or equal to your input, right? That's why we were able to include 3, because it passed these lines, right? Without jumping to finish. It only jumped to finish when we went over the input. So that when we went to 5. So it's just adding the odd integers that are less than or equal to your input, and it's returning them with this sort of V0 register. All right. So yeah, that was the purpose of the code, line by line, and yeah, I hope that helped.